Hi, hello. This is Pradita Sunkara. In our previous SQL interview question, we discussed right how index improves query performance and help queries execute faster. But creating an index does not always guarantee that SQL Server will use it. So today's interview question is, why is my index not being used even after creating it? Let's understand the reasons behind it. If the scenario is like, suppose we have an employees table with more than 10 million records, like the same what we have employee table, okay. Then we created a non-cluster index from the employees column as usual. Now we can execute the following query with the filter where clause. Then we expect what we expecting SQL Server to use the index. But when we check the execution plan, we see a table scan. The query is taking more than 25 seconds. Now, the interview question is, why did not SQL Server use the index? Okay. The common reasons SQL Server ignores an index. So there are several reasons why SQL Server may ignore an index. First one is function on indexed columns, like when we are using where clause, upper employee name equal to John. Here SQL Server must apply the upper function to every row before comparing values. Because of this, it cannot efficiently use the index. Instead of, it performs a table scan. Then second one is implicit conversion. Suppose employee ID is an int column, but we compare it like this, like employee ID equal to 101. Then here what happens? SQL Server performs a implicit data type conversion. This conversion may prevent the optimizer from using the index. So always compare the same data types. Then the third one is outdated statistics. So SQL Server relies on statistics to estimate how many rows a query will return. If the statistics are outdated, SQL Server may choose the wrong execution plan and ignore the index. So updating statistics can solve this problem. Then the fourth reason is low selectivity. Suppose a column contains only two values, that is male or female or active or inactive, like that. If an index exists, SQL Server may decide that scanning the entire table is cheaper than using the index. Then fifth one is parameter sniffing. Sometimes what happens, SQL Server creates an execution plan using one parameter value. Later, it reuses the same plan for different parameter values. That reused plan may not be efficient. This is called parameter sniffing. Then the sixth reason is OR conditions. The query like where employee name equal to John or salary greater than 50,000, like that. It may force SQL Server to perform a table scan. Sometimes rewriting the query using union all gives better performance. Then, now let's compare with both execution plans. Table scan, without using the index, SQL Server reads the entire table. It checks every row one by one. Then it applies the filter. This results in high CPU uses, high disk input or output, then longer execution time. For a table with 10 million rows, this is very expensive. Then index seek, when SQL Server uses the index, it directly jumps into the matching rows. Instead of reading the whole table, it reads only the required rows. So this result is Low CPU uses, low disk capacity, low disk input or output, and faster execution. For example, table scan may take 25 seconds, while index seek may complete in just a few milliseconds. So then many people think index seek is always better, but SQL Server is a cost-based optimizer. It chooses whichever plan has the lowest estimated cost. Then how to fix it? Now let's see how to solve this problem. Write solvable queries. Avoid applying functions on indexed columns. If the bad is where upper of employee name equal to John, that is a bad query. When what is the good querying here? When we are applying index on the employee name, then it is simply where employee name equal to John. Then the second is avoid implicit conversion. Ensure both sides use the same data type. This allows SQL Server to use the index efficiently. Then update statistics. What we have to update here? We have to update statistics on employees table. That is, update statistics employees. It helps SQL Server generate better execution plans. Then the fourth one is check column selectivity. Indexes work best on columns with many unique values. Columns with very few distinct values may not benefit from indexing. Handle parameter sniffing. If parameter sniffing causes poor performance, options like option of recompile or optimize for can help generate a better execution plan. So the sixth one is avoid complex or conditions. If possible, replace all conditions with union all. Sometimes this allows SQL Server to use indexes more effectively. Then the real-time tips, best practices are whenever a query is slow, follow this checklist, okay? Is the query searchable? Or the data types matching? Or statistics updated? Is the column selective? Or their functions in the where clause? Or condition causing a scan? Is parameter sniffing affecting performance? Then useful tools here to identify performance issues. Use these are the shortcut keys. Control plus M, that is actual execution plan. Then this is the command set statistics IO on or set statistics time on. These tools help you understand why SQL Server selected a particular execution plan. Then as usual, interview tip is if the interviewer asks why is not SQL Server using my index, don't simply answer because of outdated statistics like that. Instead of that, explain all the possible reasons. That is, functions on indexed columns, implicit conversions, or outdated statistics, or low selectivity, parameter sniffing, or condition. Then explain how to identify the issue using the execution plan and how to fix it. So this demonstrates real world troubleshooting experience. I hope you understand why SQL Server sometimes ignores an index. Remember, simply creating an index does not guarantee that SQL Server will use it. So writing efficient queries, maintaining statistics and analyzing execution plans are the keys to the query optimization. So thanks for watching. Subscribe for more real world SQL interview questions and performance tuning concepts. Thank you.